Welcome everyone to my talk today. I'm going to talk, as Dominic already mentioned, about identity management. At the end, I will show you a simple showcase with a simple demo application that you can then use or not use if you like to. It's a very, very simple one. But before we are going into all of that, what makes the most fun probably is, as you probably know me, a small wall of text. Some stuff we need to know. Why do we do this stuff? How is it called? How does it work together? And so on. So then I will start with the first presentation slide in the jungle with our new design. Again, welcome to the Jungle Academy. The identity management I'm going to show you is the one of the use cases. It's one thing we are using all the time, probably don't knowing for exactly what how some of the stuff really happens, how does it really work, and so on. Identity management can be done with multiple solutions, frameworks, and so on. Today I've chosen the, I think, in our world, most important one, OpenID Connect. So the agenda for today, I'm going to give you another short introduction to identity management. Then I'm going to give you a little big overview, or a little bigger overview on OpenID Connect. What is this? And also on OAuth. What is this? What are some key terminologies? And so on. After that, we're going to look into some claims and scopes, which is pretty useful for the following stuffs. And then I'm going to tell you a little bit about single sign-on and why it matters, and we all probably love it. Then some consideration and best practices that I think should always be mentioned when running around in such environments and using such topics. And then at the end, I think the most interesting one is the demo time. I will show you an application that uses identity management that is built with .NET 6, Next.js, and the identity server. And of course, it's using OIDC and the authorization code flow and the delegation flow. If you don't know what it is, at the end of this talk, I hope you're fully aware of what this is. Then we'll directly start into the introduction. So why do we do identity management, or what is it at all? Identity management refers to the processes, the systems, the technologies that are used to manage and control user identity within an organization's digital ecosystem. It encompasses the administration of user accounts, authentication, authorization, the management of user attributes, their access privileges, and so on. So identity management plays a crucial role when we want to ensure secure and seamless access to our resources within our applications, especially within enterprise applications. So a few more words about that. So user authentication and authorization, identity management enables users to securely authenticate themselves, and therefore they can gain access to resources, and we can ensure that they are granted based on their roles and their permissions. So single sign-on and user experience, where does it help? Where does identity management help us? And that it allows users to authenticate once and then access multiple applications all over. So we don't need multiple login credentials, and overall increase productivity and also a bit of the security. Also, it can help us with regulatory compliance. So it helps organizations to adhere regulatory requirements by implementing robust security measures, such as strong authentication, strong access control, and also very important audit trails. And therefore, we are more likely to be able to fulfill regulations such as the GDPR or the CCPA. Also, it helps us with provisioning and deprovisioning, so we can effectively get users that are offboarded from a company, get out of all of those systems that they are now no longer allowed to do. And also the provisioning, so we're much more easy. It's much more easy for us to onboard humans or accounts. So the next point is also, when we're doing this, it's not only helping us on a few points, it's also giving us some challenges, and we're also having some risks. So managing user identities in public-facing applications is all, again, introducing some unique challenges and risks, and the reasons, therefore, are, at least what I do see, and there are probably much more out there, it's the scale and the complexity. So we have large user bases, we have diverse user roles, and we have very complex access control requirements. Managing all of that can be very challenging for overall if it's managed in a secure way. Next big point would be security threats. If our application is public-facing, everything you can do that's not good for our application will be done. So that can lead to data breaches, reputational damage, which is probably the worst one, and also financial losses. Then what we also have to take in concern are privacy concerns. We must handle the user data appropriate. The user experience and the usability, it's always this thing, we need security, but we also want to have a convenient way to use our applications. And therefore, it's always a trade-off. What does identity management also a challenge when we are using it? It's the federation and interoperability. If we're having multiple identity management systems involved, just like we're building an application and we have to connect this with the Azure Active Directory or our own identity providers or what else you can think of. This is also most of the time at least a small challenge. And again, the compliance and auditing is where it helps us, but also where the challenge lies. So addressing these challenges and mitigating these associated risks requires a robust identity management strategy. So we need to think of all of that. And luckily, a few very intelligent guys, or humans, not only guys for sure, created and developed the OpenID Connect specification. Sorry for that, I didn't find the word. And this will help us. And now, perfect direction to OpenID Connect. Let's take a small look into it. The OpenID Connect is an identity layer built on top of the OAuth 2.0 framework. It provides us a standardized way for clients like mobile or web applications to authenticate end users that are also called resource owners and then obtain their identity information from an identity provider. I have to take some water. And what also OIDC also enables us is secure authentication, the identity verification, and especially the exchange of user information in a structured format, which is very important. As you all know, standards will help us. It was all created by the OpenID Foundation, which you can easily Google and find a specification, which is free to use. Now let's get into some terminology that is usually used with OpenID Connect. Everyone who has some knowledge about OpenID Connect and OAuth will now probably know what's going to be a problem when I'm going to talk about this. The differentiation between OIDC and OAuth is most of the time not done correctly. And it's always pretty hard to determine which is what because one builds on top of the other. And if I'm going to make any mistake by talking on that, I'm sorry for that. I really try to distinguish between those two, but sometimes it's just messing around with me. But now let's get into the terminology. So The ID token is a JSON web token issued by an identity provider. Sorry, lost place. And the ID token contains the information about the authenticated user as a proof of their authentication. So with the ID token, we know who it is. And the ID token also includes claims, also called user attributes, just like the name, the email, or any other relevant attribute. We'll come out to that at a later point. Then OIDC also gives us, with its specification, and user info endpoint where we can get much more information about the user if the user allows us to do that. As well, there's more information than what is already included in the ID token. What OIDC also gives us is the discovery endpoint to have a much more easier integration when we only have to know one endpoint, and with that endpoint we get all the other endpoints that we need to do, that we need to know to do our job. Just like with ACME, the Automatic Certificate Management Environment, this does it in a very, very similar way. What's also important and nice, what's coming from OpenID Connect is the session management. It's a very essential aspect of OIDC, and involves also the maintaining of the secure session between the user and the identity provider. And therefore it keeps the state of the logged, if the user is logged in or not, across multiple requests. This is very helpful, as you probably all know for sure. Then another thing, I already mentioned it, are claims. Claims are pieces of information about a user that are included in the ID token or obtained from the user info endpoint. That are such things just like names, email, profile, pictures, roles, and so on. As said, we will come up to that at a later point. But not enough with that, we are having more. So the user itself, it's, as mentioned, known as the resource owner, the one who some data belongs to. It's the individual, just like you or me. And also, the client is a very important word in this space. The client is an application or a service that wants to authenticate the user and obtain information about their identity. So it's usually a backend API or a CLI tool or a web app will usually use such OIDC client or OAuth client to identify itself. Then the identity provider, as mentioned, is responsible for authenticating the user, providing the identity information to the client. And the IDP is usually a specialized authentication server that also implements the OIDC protocol. What an authentication server is something that I will explain in a few slides. Sorry, I will gonna explain it directly. Sorry for that. The authorization server is responsible for handling the authentication and the authorization process. This is the one who is validating the user's credentials and issuing the tokens itself. Then the connection of both is the OpenID Connect provider. This is as said, the combination of both. Pointing out to later what the Dynde identity server does, what the identity server earlier was. The identity server got to the Dynde identity server is explicitly this one. So if all these components now work together, they enable us to do a secure authentication and a pretty good working identity management with OIDC. So then the clients will interact with the identity provider or directly the OIDC Connect provider, and then this one does authenticate the users, issue the ID tokens that contain the user information, and then our client can do whatever it needs to do with this information. So to more directly point it out, I'm now going to explain a little bit about the role of OpenID Connect in the identity management. I mentioned a few words, but I think a little bit going deeper in that could help us. So the user authentication is one point where OIDC facilitates the user authentication by leveraging an identity provider. Also, it provides a user-friendly authentication flow that allows clients to authenticate users without directly handling their credentials. This is one very important point. We do not have to handle credentials in our applications. Then also the identity verification. It OIDC enables those clients to verify the identity of the end user by obtaining the identity tokens from the identity provider. This can help us to make sure we know that who they are. Also, one important role in the identity management is user consent and control. It incorporates the consent mechanism, allowing users to grant or deny permissions for clients to access their identity information. So the users have control over their data, which is in the meantime, or honestly, since the beginning of time, something very important because it's our data. Then one more thing where it plays a crucial role: single sign-on, making it easier for everyone using our applications. So now, as I mentioned, OpenID Connect is built up on OAuth 2.0. I will show you now a few things where it is using OAuth 2.0. So the ID token is introduced by OIDC. It's a new token type. This was not included in the OAuth 2 framework. And as mentioned, it carries identity information about the authenticated user. Not usually, always, the ID token is a JSON Web Token, the so-called JWT, which is signed, and our claims are then signed, and we know what it is. And we can be sure that this is the correct information that was not somehow manipulated. OpenID Connect also adds a new endpoint called the authentication endpoint, which clients then can use to initiate the authentication process with the identity provider. The identification endpoint handles user authentication and returns the ID token and other relevant tokens to the client. I need some water again. Also, OIDC introduces a discovery mechanisms where clients can retrieve metadata from the IDP to discover the necessary endpoints. I mentioned that again. I mentioned that earlier because it's very important. It helps us very, very much. Also, OIDC specifies a few flows, which are honestly mostly were already introduced with the OAuth 2.0 framework, but by using them, it helps us in a pretty good way. So by building upon the OAuth 2.0 framework, OIDC provides a standardized and interoperable and secure solution for user authentication and identity management in our applications. And we can enhance the security, the user experience, and also enable seamless integration with other IDPs. And therefore, we are going to have to handle less authentication stuff on our own, which makes our application by default more secure. Now, as talked about OAuth 2 a lot, we're going to get a little bit introduction on that, and then also I'm going to explain a few terminologies on that, just to get you to the point that I can show you the fun part. Yeah, the OAuth Open Authorization is an open standard framework that enables secure and delegated access to protected resources on behalf of a resource owner, usually a user, and by allowing third-party applications, e.g. clients, to obtain limited access to those resources without even exposing the user's credentials. So the primary goal of OAuth is to provide a secure and standardized method for authorization, allowing users to grant access to their protected resources hosted on a server. This is usually known as the resource server. And this is granted to external applications or services. These are usually known as clients. And very important, again, without sharing their login credentials. So just to mention it, OAuth 2.0 is, in difference to OpenID Connect, available as a request for comment with number 6749. And in the future, it will probably be replaced with the OAuth 2.1 authorization framework, which is currently developed. One more word about the change that will taken place after the 2.0 framework is replaced by the 2.1 framework. A few flows will become obsolete. So it's a good idea to not using them anymore. I will mention them if we're talking about the flows. So then let's get into some terminology. So the resource owner is the user who owns the protected resources and grants authorization to clients to access those resources. So the resource owner could be an individual user or an entity with control over the resources. But the client is the application or service that requests the protected resources on behalf of the resource owner. It can be a web application, a mobile application, or any other type of client that interacts with the OAuth 2.0 server. The authorization server is the server that is responsible for authenticating the client and the resource owner. And it's also issuing the access token if the authentication authorization was successful. So it handles the entire authorization process and is responsible for validating client credentials, verifying user consent, and generating and issuing access tokens. So the resource server is the server that hosts the protected resources. Usually that's our API. It validates access tokens presented by clients and grants access to the requested resources if the token is valid and has the necessary permissions. Then the authorization grant is a credential representing the authorization given by the resource owner to the client. It is used by the client to obtain an access token from the authorization server. The framework defines several types of authorization grants. The authorization grants are also known as flows. So I usually refer to them as flows. So there are several defined. I will now name a few, but we will come up to them later again. So it's the authorization code flow or grant, the implicit flow or grant, the resource owner-based credentials flow or grant, and the client credentials flow or grant. Then another important thing in the OAuth world is the access token. Most important probably. The access token is a credential that the client uses to access protected resources on behalf of the resource owner. It represents the authorization granted to the client and is presented to the resource owner along with each request for accessing protected resources. That's the thing we usually put into the HTTP authorization header as a bearer token. Another type of token is the refresh token. This is an optional credential that can be issued along with the access token. It allows the clients to obtain new access tokens without involving the resource owner. So access tokens have usually a pretty short lifetime and refresh tokens have a longer one. So we can do something in behalf of the user when we use the refresh token also when the access token is already invalid, not invalid, expired, sorry. So then scope is a parameter, that's very important, that is used by the client to specify the permission it requires when requesting access to the protected resources. Scopes define the extent of access the client is requesting. They can be used to limit the client's access to specific resources or actions. So therefore, you should not always request every scope your user can have when you try to access something. You should always only request the scopes you need, and therefore you limit the access of the token and do a little bit for the security. Last but not least, the redirect URI. The URI is where the client is redirected after the resource owner authenticates and grants authorization. It's used in the authorization code flow and in the implicit flow to deliver the authorization code or access token to the client. So this is where the identity provider delivers the actual access token or authorization code back to our application. So these components now work together to enable the authorization process in OAuth. The client obtains an authorization grant from the resource owner, exchanges it for an access token from the authorization server, and then uses the access token to access the actual protected resources on the resource servers. As said, we are going to talk a little bit about flows, and then we will start with it right now. So OAuth flows, also known as grant types, are methods through which a client application obtains access to protected resources on behalf of a user. Each flow serves a specific purpose and has its own set of use cases and security consideration. Here's a brief description, really only a brief description. I picked two that we will take a little bit deeper look into, but with the rest, we're just going to take a short overview on that. So first one, I think one of the most important ones that we honestly all should use is the authorization code flow. It's also the commonly used one and the most secure flow. How does it work? The client application redirects the user to the authorization server where they authenticate and authorize the client. Upon successful authorization, the authorization server issues an authorization code to the client, which is exchanged for an access token, and the access token is then used to access the protected resources. The implicit flow is something which is absolutely not recommended and will also be obsolete in OAuth 2.1. This flow is suitable for browser-based applications or mobile apps without server-side components, something which usually should not happen in our world, or if then you have a very specific use case. So the client application receives the access token directly from the authorization server after the user authorizes the client. There's no authorization code exchange involved, and the access token is directly returned to the client, which is usually not that good. We are going to take a little bit deeper look into that when we're talking about some consideration and best practices. And then the client credentials flow. This flow is used when the client application needs to access its own resources or perform actions on behalf of itself. So it's usually mostly done only in the backend and only requires a client ID and a secret. And as no user is involved, no user is involved. Then the resource owner password credentials flow. This is something that is also going to be deprecated and obsolete, and out of obvious reasons, I think. So this flow is used when the client application has the resource owner's credentials and can directly exchange them for an access token. It is very less secure, and the client itself needs to store the user credentials. Then the device authorization flow. This flow is designed for devices with limited input capabilities, such as smart TVs or gaming consoles. Well, gaming consoles, I don't know, not really a good example. The user visits a verification URL on another device, such as a smartphone, and authorizes the client application. The device then calls the authorization server to obtain the access token. It's also the same thing the Azure CLI does. Then the refresh token flow, mentioned before when talking about the refresh token. So this flow is then used to obtain a new access token when the current one expires, and we don't need any user interaction. Then, last but not least, and also it's an extension grant. It's not defined in OAuth 2.0 itself, but it got extended. The delegation flow, or token exchange grant, is also a name of that. Also in the delegation flow, the client application obtains a delegation token from the authorization server, which represents its authority to act on behalf of the user. Then the client presents the delegation token to the target application or service and gets the granted access. So every flow has its advantages and some considerations. So the choice depends on many things, but overall, really think if you're not using the authorization code flow, why you're not doing this. Now, we're not going to stop to talk about flows. We're going to take a little bit deeper look into the authorization code flow. So if you ask yourself, how was this diagram created? It's D2 in sketch mode. So what we now see is as a diagram, but I already told you. I'm gonna do a short explanation on that to not bring you all to sleep here. So the user clicks on the login link on his on the web app. Then the web app, I can use my mouse, then the web app requests an authorization code on the authorized endpoint of the authorization server or identity provider. The authorization server then redirects the user to the login authorization prompt of itself. This is a little bit simplified for sure. And then the user can authenticate and consent to the wanted resources. Yes. Then, if the user authenticated and consented the access, the authorization code is sent to the web app application, so not directly to the user. And the web app uses the authorization code, its client ID, and its client secret to get a token from the token endpoint. Then the authorization server validates the data it just received and issues an ID and an access token. And then the web app can request the user data with the access token and receives it from the API. Yes, there's one thing to mention before. You have to set up the client that is used by the web app on the identity provider. So therefore, you usually use need when using the authorization code flow a client ID, a client secret, and yes, at a redirect URL. I'm sorry for that, because the authorization server needs to know where to redirect the user. Then we're going to look at the delegation flow. Yeah, I already told you that. Now we're going to look into the delegation flow. The user in the beginning does some action on the web app. The web app already has the access token of the user because he's already logged in. The access token itself contains values or like the client ID, which are now called web app. The sub is the subject, which is the user ID, and it also includes the scopes used within this token. This is super simplified. And then when the web app has this access token, it requests some data at my API. Then the API needs to access my second API to get all the information it needs to fulfill the request. And now, as we want to have a secure system, and the user should not usually, so the web app should not be allowed to directly access the second API, and therefore the client of it is not allowed to use the scopes to access the second API, but my API, the client that my API uses, is allowed to do that. So the my API sends a request token exchange request to the authorization server and says, hey, I want to access this scope, please give me an exchange token. Then the authorization server returns the exchange token with one very important thing to point out. It reserves the actual client who did it. So obviously I made a mistake here. This is not web app. This is client ID is my API. And then we can see we have an access token issued for the client ID my API, but also still know who was the originator, the client ID. So this was my API. This was my web app. I'm sorry, I just directly switched it. So we do not lose any track of it. We know who was it, but we also ensured that the first client in the row is not able to access the second API. Yes, pointing out some key differences between OIDC and OAuth. As I mentioned, it's one is built on top of the other, and features get added. So it's sometimes a little bit confusing. So when we talk about the purpose, OAuth is primarily an authorization framework. This enables a secure access delegation. It allows users, resource owners to grant a client applications access to their resources, such data or services, and especially without sharing their credentials directly. So OpenID Connect is an identity layer built on top of OAuth. It adds authentication capabilities to OAuth, enabling the client application to authenticate the end user by leveraging an identity provider, so not being required to do it on their own. So when we talk about authentication and authorization, OAuth focuses on authorization. It allows clients to obtain access token to access protected resources on behalf of a user. It does not really provide explicit authentication mechanisms, but for sure they're needed to actually authorize them, because if someone is not authenticated, you should not authorize them. And on the other hand, OIDC extends OAuth by introducing an authentication layer in a standardized way. When we talk about user information, OAuth does not really specify a standardized way to retrieve user information. It's about securing access on resources. On the other hand, OIDC defines a set of standardized claims that then can be requested by clients to obtain user information such as name, email, and profile details. When we talk about end user experience, it can be easily put into two sentences. OAuth primarily operates behind the scenes, and OIDC emphasis on the end user experience. So another thing to mention is maybe the protocol layers. OAuth operates on authorization layer and OIDC on authentication layer. And now we have done it. We finished the OpenID and OpenID Connect and OAuth chapter, and now I'm going to jump into the claims and scopes, which means for reality we're pretty close to the demo application. Yes, so claims in OIDC are pieces of information about an authenticated user that are asserted by the identity provider and included in the ID token. Claims can include standard attributes like name, email, and profile information, as well as custom attributes defined by the IDP or the application. So it's providing us user information. Scopes define the permission or access levels that clients request during the authentication process. Scopes determine the type and amount of user information and resources the client can access. The IDP uses scopes to control the release of specific claims and authorize client access to protected resources. So it's more or less about controlling access to resources. Now I will show you a few common claims and scopes and say one or two words about it. So the most common claims, I would say, are the subject. It represents the unique identifier for the authenticated user. So when you're using ASP.NET Identity, there's the GUID inside of the identity user. The name is the full name of the user. The email is the email of the user. The picture is a URL to the picture of the user, and the birth date is the birth date of the user. Pretty obvious. It exists a list in the OIDC specification that is much longer, which defines the default ones. So scopes defined by OIDC, as scopes are initially defined as a thing itself by OAuth. So directly defined by OIDC are now the OpenID. This just indicates that it's the basic OpenID Connect authentication. Profile, when you have the scope, you get granted access to the user profile information with email, same for email. Interesting, I think, is the offline access. It enables us to use refresh tokens. Anyone who has ever maybe used the API from Microsoft knows this. You always require that. Yes, and if those default ones or commonly used ones are not enough, you can customize them. So you can have custom claims to add additional user attributes that are specific to your application or your business requirements. And with this, we can do that. Custom scopes can also be added, and therefore we have additional permissions. We have access to specific resources behind the standard ones. So we can provide a more fine-grained control over access, even more fine-grained control to our resources. Then I'm going to be a little bit faster that we can get up to the demo application. As I see, it's already a little bit late. And then we're going to single sign-on. So single sign-on is an authentication mechanism that allows users to securely authenticate once and then gain access to multiple applications or services without the need to re-authenticate for each individual application. So what does SSO gives us when thinking about benefits in an enterprise application? SSO simplifies the user experience by eliminating the need to remember and enter multiple sets of credentials for different applications. So SSO also reduces the risk of associated with password-related vulnerabilities. Users are less likely to reuse weak passwords across multiple applications since they only need to remember one, or better, they use a password manager. Also, the most identity providers allows us to use a multi-factor authentication. SSO also centralizes user provision and management, making it easier for everyone who has to handle and manage them. So SSO also provides us a centralized audit trail for user authentication and access to applications. Yeah, then OIDC and seamless SSO experiences. I'm gonna get a little bit fast on that. So we can use OIDC as a SSO protocol. Now we have single authentication for multiple applications, and we have token-based access control. Also, what is very nice, it allows us to use federation. So we can use a third-party identity provider to authenticate users that can then work in our system. Then the topic I'm not going to be slow down because I think it's very important. It's considerations and best practices. And we'll start with some considerations. It's about secure token handling. So we should use secure token storage. And it should be securely stored and protected from unauthorized access. Very, very important. Also, secure transmission. So we should always use HTTPS. When talking about expiration, token expiration and refresh times, we should use appropriate token expiration times. So access tokens should be pretty short-living, and therefore we should use token refresh mechanisms to still be able to still work without always needing some user interaction. Then what is also very important, it can always happen that some token gets stolen and then we need to revocate it. We need to have these mechanisms for a secure system. Then we have to ensure that our tokens are validated and verified. So we should verify the token signatures, we should validate token audience and issuers, and we should implement logic to validate the token itself. So is the issue correct? Is the audience correct? Is the scope correct? Does all of this make sense? We should also protect ourselves against common threats like phishing attacks, replay attacks. And for this, we should use strong authentication and authorization practices. And we should employ secure coding practices. So think about injection attacks, cross-site scripting, cross-site request forgery requests, and so on. The list is very, very, very long. So it's very important to regularly review and update your security measures to stay up to date with emerging threats and vulnerabilities. Additionally, you should consider, if you're not that good or not have that knowledge in that field, asking someone who has that knowledge to get the help to do it in an acceptable way. Yeah, I was skipping the slides, sorry. Let's talk about best practices. We should always use a secure configuration, as mentioned, HTTPS. We should configure strong encryption algorithms. We should disable insecure features. Also should not use deprecated flows or close to deprecated flows that are just unsecure by default. We should do a proper client registration. We should register clients securely, so everything should fit. We should obviously use client credentials for each client and not one for all. We should secure our token storage. We should protect them at more or less every level. We should also use the session management and implement it in a secure way. And we should always should also add session monitoring and their revocation method to allow users, or especially us as developers or administrators, to stop sessions and kill them if we know there's something wrong. Just like, please kill all my sessions on all devices if your Facebook account got hacked. Yeah, then about best practices, consent and user experience, we should always think about what is good for the user. So it should be easy for them, but secure. We should always be clear about consent. We should allow them to do it in a fine granular way, not just, we need all of your information, so maybe we only need the email, and then we should only ask for the email, which is also regulated by the GDPR, that we only should do that. And therefore, we should optimize the user experience. And as mentioned before, regular security audits and updates. Very important thing. Now, the wall of text has ended. And it's demo time. Therefore, I will switch to the application, to GitHub itself. And I will show you the repository we will now talk about. Give me a second, please. So it's a public repository that is made of Next.js, the identity server, and ASP.NET Core. This is super simplified just to show what happens in there. So if you're opening it up on yourself, you will get many, many warnings, especially in the front end, as I'm usually a backend developer. And I was just wanting to point out how stuff thing where you can just look into, get some ideas about how it works, and then if you need to, just fork it and do whatever you want while playing around. So I already checked this out, obviously, as I wrote it on my own, and I will now start by showing you the front end, how it more or less works. So we're having our web folder. It's a one big repo, everything's in here. It's a Next.js application, therefore we're using React for rendering. And the most important thing, I think, is for now that we are using the next authentication with the identity server 4 provider. I know it's deprecated, but it just works out of the box. And the new one is should be coming soon. That fits to the identity server. And yeah, as we can see, we named it identity provider. We added the issuer so that we can know who issues our tokens. This is the authorization server, the identity provider. We added our client ID, our client secret, and we said, okay, we need these scopes for our application, and we use the grant type, the flow authorization code, and the authorization URL is the authorization endpoint at the identity provider. So now, as it's an npm application, I will start the application, npm run dev. Obviously too hot for my laptop, and it's take a second. As said, ignore some warnings if you would be nice to me. So in the backend, we are having an identity provider, which is just the quick start code of the Dynde identity server adapted to my needs. So what would we do? We added a token exchange grant validator to even allow us to do the delegation flow, which I will also show you. And the whole frontend is added by default. Yes, so then I will start it. And as you can see, we have our statically typed configuration right here. We can see there's a client, which is a machine client. There's a client, which is machine client delegation. And there's a web client as a client. So the web client is used by the web application. The machine client delegation is used by the backend API 1. When talking about API 1, I'm going to show you the backend. This is just something very, very simple with a mighty data controller and nothing else in there. We're going to start the backend API 1. The API 2 is exactly the same. The only difference between those APIs is that you need different scopes to access them. Now that I started all services, they're up. I'm going to show you. And everyone who has some feeling for front end, please don't kill me. I don't have it. So right here, we have a very, very simple application. I'm going to inspect it to show you just a network traffic, which is nice. And when we now press on login, the authorization code flow starts. So it will, in the Next.js server, will request an authorization code from the authorization server, and as we are not logged in, we get redirected to the authorization server as a user and have to grant our consent, and then can log in. So now we are moved to the identity provider. So it's as usual, some dummy users are created, and for sure it has to be Alice. And now we can see we are logged in. We had a whole lot of requests. We got a redirect from our provider, from the identity provider, and ended up here. Here we received our token. And there we go. So if we're now going to data 1, you can see, or you should see, yes, there is some data coming up. And this is just a rendered JSON that received as an answer from the API 1 data. And if we're now pressing on data 2, we will see that we received API 1 data, but with content API 2 data that is mighty. So if we jump into the backend, we can see that in API 1 in the controller, we're having 2 endpoints. And when we call data 1, we access just the backend 1 mighty data, which just delivers our API 1 data that is mighty. But if we access mighty 2, we actually access the mighty data from the backend 2. And to access this, we need another token because the client for the web application is not allowed to access the API 2, and therefore we do it within the API 1 and create get an exchange token. I will show you. Therefore, we'll just do nothing else than sending a token exchange request. So we're getting our discovery URL to know what actually happened, to know where to send stuff to. Then we send a token exchange request, and we just have to add the original period JWT token, and then we can get this with the newly created requested scopes, which are here. Therefore, we are able to deliver the data from API 2 by API 1. I wanted to get into a little bit more details, but as the time is pretty far, I would just stop it right now and say thank you for listening.
Vielen Dank für den tollen Vortrag und ansonsten wünsche ich dann jedem ein schönes Wochenende und wir sehen uns nächste Woche wieder.